Hi everyone, welcome again. In this video, we will do some hands-on. We will see how to create event-driven microservices using Apache Kafka. So let's see what we are going to cover. The first step is to run Kafka on local. Once we have the Kafka up and running, we will create an order topic. That topic will store order created events. Next step is to develop the order service. The responsibility of order service is to create the orders in the system, and once it does that, it will generate an order created event that will be stored or sent to the order topic so that interested parties who are listening to this topic can react. Then we will develop the notification service. This notification service will listen to this order topic, and whenever there is this order created event on the topic, it will read that order created event and then it will do something about it. In this demo, it can be as simple as printing the message on the console, but in real time it can shoot an email or SMS, and it can further generate an event, let's say notification sent, so that any other downstream application who is listening to that topic can react accordingly. So let's get started. The first step is to run the Kafka on the local system. There are different ways to run Kafka. We can use Docker containers, we can use a cloud offering, or we can download the Kafka and run it on the local system. So I'm going to show you how to download the Kafka and how to run the Kafka on Windows system. To download Apache Kafka, we can simply Google Apache Kafka download. Let me show you that. So here, if you Google Apache Kafka download, probably the first link that you will get is from the Apache Kafka. So go to the download section, and there we can find all the Apache Kafka versions. And this is the latest one as of now when I'm recording this video. And you can see under the binary downloads, there are two versions, Scala 2.12 and Scala 2.13. And here it says it only matters if we are using Scala. If not, we can simply go with 2.13, which is the latest one. So if you click on this link, it will download the bundle on the system, and we need to extract it somewhere on the directory. So you will have the folder Kafka. Let me show you mine. So here I have extracted the bundle and renamed the folder to simply Kafka, and you will get a similar directory. Now all the executables are in the bin directory. So we need to go to the terminal, to the bin directory, and then we can start running Kafka by running the executables. So let's go to the terminal. And the first thing we will do, we will run Zookeeper, because Zookeeper is required by Apache Kafka. To do that, to run the Zookeeper, let me copy the command. Here it is. So in Kafka directory where we are, we go to the bin directory, and there in the Windows folder, and there this is the bat file that we need to run, Zookeeper server start. And then we need to provide the Zookeeper properties, which is in the config directory under the same Kafka directory. So let's hit the enter, and it will start the Zookeeper. All right, so Zookeeper is up. Once we have the Zookeeper up and running, the next step is to run Apache Kafka. And in the same way, we will go to the bin directory. In the Windows folder, we will find the executable for Apache Kafka. So let me copy the second command as well. And we will now open a new terminal. Kafka, and this is the second command. In the same way, in the bin folder, Windows folder, there is this executable Kafka server start, and in the config folder, there is this property file server.properties, which has relevant properties related to Apache Kafka. Hit enter, and it will start the Kafka server. So as you can see, Kafka is now up and running on my local system, and notice this is a single node, a single machine. So in the cluster, there is only a single node which is running on my local system. Once we have Kafka up and running, we will create a simple topic to use it in the demo. So let's do that. Open a new terminal. And let me copy the command. Here is the command. So in the Windows folder, in the bin directory, there is another executable which is specific to Kafka topics. And we are saying we need to create a topic. The name of the topic is order topic. And we are not defining any partition or replicas because we have a single node running. So if the partition is 1 and the replica or the backup is 1, it's fine. And we are also providing the bootstrap server. That means where to find the Kafka. So this is running on the local host with the default port. And if we run this command, it will create an order topic, and it says it created order topic. And we can also describe the topic that we just created. There is another command, and here it says describe the topic, this one. And we are also providing the bootstrap server. This is something that we have to provide. And let's run the command, and it will simply provide the details of that topic. So we see the name of the topic is order topic. It has 0 partition, which is 1 basically, and this is the leader because there is a single partition, so that alone is the leader of that partition, and there are no replicas. Okay, so we have successfully started Apache Kafka on the local system, and we have created a simple topic. And now we will start developing the microservices to use this topic in the demo. Let's move on. To develop the microservices, we will go to Spring Initializer, and this is going to be a Maven project. Let's change the group. The name of the artifact, this is going to be the order service. Let's add the dependencies. It's going to be a web API, a Spring Web application. So we need to add the web dependency, which is Spring Web. And the next dependency is for Kafka. And this is the one we are going to use, Spring for Apache Kafka. And that's it for the demo. We need only these 2 dependencies. Let's generate the project. And similarly, let's create the second service as well, which is notification service. This notification service will also be a REST API, and it will poll the Kafka topic to read or to fetch new events. So we need the Kafka dependency in this service as well. Let's change the name. Okay, and generate the second service as well. So we have code generated by initializer for both the services. Let's open them in IntelliJ. So here we have the order service. Let's open this with IntelliJ. And while it configures the project, let's open this second service, which is notification service as well. This is the notification service. I'm going to open it with IntelliJ. So the projects have now been configured. This is the order service, the first service that will create the order, and it will generate the event. And if we check out the pom.xml, we have simply the starter web and Spring Kafka. All right, let's go to the application.properties file, and I will simply change the server port just to avoid the conflicts. And we can do that by providing this property server.port 8181. So the project has now been configured. Let's check out the pom.xml, and here we have the simple starter web and Spring Kafka dependency. Let's go to the application.properties, and we will change the port to avoid the port conflict because we will run different microservices. That we can do by providing this server.port configuration, and that is going to be 8181 in my case. Let's add a controller. So let's add a new package. And in this package, we will add a new class. And now we need to add the required annotation, which is REST controller. And in this controller, we will have a simple method order. So this method will return a response entity of type string, and this is going to be a post method. We can do the same thing with get, but here we are showing that this service will create an order, so that's going to be a post request, and that's why this method is annotated with @post mapping. As for the input data, we will use the annotation request body and a simple string input order. All right, and now for this demo, we will not do anything else in this method. We will simply log the order, the string that we receive as an input. And the important thing is to create an event, to shoot an event to Kafka for the consumers. All right. So let's do that. Input order. Order. And we need to return a response back to the client. So we will say response entity.ok. Order created successfully. And then we need to trigger an event here. So how do we do that? We need some mechanism to access the Kafka cluster in order to send an event. And how do we do that? Well, we need to use Kafka template, a class provided by Spring Boot that we can use to access or to interact with Kafka. And the good thing is we don't have to do much in order to access that Kafka template or to create the Kafka template. If the Kafka is running on the local system with default configurations and default settings using default ports, Spring Boot can locate that cluster and it will auto configure the Kafka template that we can simply use wherever we need that. And in this case, we have the Kafka running on the local system. We have not changed any port or the host name. So Spring Boot will find that Kafka. All we need to do is we need to use that Kafka template. We need to provide the key and the value. And in this case, it's going to be simple string and string. And we need to auto-wire it like this. Now, what will happen when we start this service? Spring Boot will see that, okay, we have this Spring Kafka dependency in pom.xml. So that means we want to work with Kafka. Then it will try to find the Kafka running on the local system. And it will see that there is this Kafka cluster up and running. There is only one node. And accordingly, it will configure this Kafka template. And that Kafka template will be injected in this order controller because we are using @auto-add annotation. So we get a working Kafka template. Once we have the Kafka template, we can use this Kafka template to send the messages. To do that, we can say Kafka template dot send. So here you can see different variations of send method. So this one accepts the topic and the data. This data is the actual record, actual message, or the body of event. Now we can have an object as an event. We can have a sophisticated event, a complex event. But in this case, we will simply create a string event that will hold a simple string value. And similarly, we can send the producer record. And in this case, the producer record will have all the information like the topic, the partition, the payload. We can also wrap that payload in the form of message, and then we can send the message object using send method. And similarly, we have topic, partition, timestamp, and everything. All right. We can also pass the key while passing the event. We will see how can we use the key. So for now, let's use the simplest method, which accepts two values, the topic and the data. Now the data is going to be what event we want to generate. So in this case, we want to generate a simple string event. And let's say the payload in this case is order created. And then we can append the order ID. All right. And what is the topic? Remember, we created a topic for the demo, and this topic is order topic. So let's copy this and paste it here. So this will now send this event, basically this payload, to this topic. And we can listen to it. So we can say when complete, do something. Send result and throwable. So what we are saying here that please send this event to this topic. And when you do that, when it's complete, we want to check out the results and if any exception which was thrown. So we can do something like if throwable is null, that means there were no errors. So in that case, we can explore the result. In this case, send result. And if throwable is not null, it means something went wrong. We got an error back, and we can simply print this stack trace, for instance. All right. This is a very simple use case where we are generating an event and we are sending this event to order topic created by us. All right. So that completes the producer part. Now let's move on to the consumer, which is the notification service. This is the notification service which acts as the consumer of those events. And if we check out the pom.xml, we have the same set of dependencies, boot, starter, web, and Spring Kafka. And similarly, we will change the port, server.port. Let's name it 8282. And in this case, because we simply need to read the event, so we can exclude writing a controller. We don't need a controller in this case, but still add a package. It says consumer And here we need a class order event listener. You might be thinking, why a listener? Why not a controller? The thing is, this is not a synchronous communication between two services. This is async. In fact, in event-driven architecture, services are decoupled, which is the case here. Order service has no idea that there is a notification service. So what our order service is doing, after creating the order, it is simply generating an event and putting it in Kafka. And similarly, notification service has no idea where is this order service. All it knows that I have to read the order created event from this topic. And that's why we create the listener, which can be notified whenever there is a new event or whenever there is a new record on that Kafka topic. So that's why we have this listener. Now in this listener class, which is the plain Java class, we will add a new method to consume the event and to do something about it. So for this demo, we won't do anything. We will simply write a method consume order event, and we will accept that event, because in this case the payload of that event is a simple string. So that's what we are going to accept, string record. And then we can log this received event record. That's it. In real life project, we can do something on the basis of this event. It may shoot an email, it may trigger a message to the subscribers. Now, how do we bind this listener to the Kafka topic? To do that, we will use a new annotation, Kafka listener. And it requires some properties. First of all, the ID, let's give it an ID. We will say order event listener. And the second one is topics. Now here we need to pass the topic that we are interested in. In this case, the name of the topic is order topic. So we can copy that from the order service. This is the name of the topic. And that's it. What this will do, it will register this particular method as a Kafka listener with an ID, which we have provided. And we have also provided this topic, that this is the topic in which we are interested. So in case there is any event, a new message is produced to this topic, please notify me. So whenever there is a new event, a new activity on this topic, this method will be invoked by the framework, and the payload or the body of that event will be passed. So we have completed the setup. Let's now start the services and test this whole setup. Let's start with the order service. Let's start the order service. And we can see that the service started fine on this port. Let's start the notification service. And the notification service is also up with port 8282. Now we need to call the order service, because whenever a new order gets created, this service will trigger an event. It will call its order controller and it will send a new event to this topic. And notice that this method is a post method. It's using this post mapping annotation. So we need to make a post call. To do that, I'm going to use the postman. So let me open my postman. So in the postman, open a new tab and change it to post. We need to use the first API, which is the order API, and this API is running on 8181. That's it. And now we need to pass the body. So we will go to the body tab, and using the raw, we can pass order 1, which means we are creating a new order. This is the ID of that order, order 1. And if we hit send, and we see the message order created successfully. So if we go to the order service, we see the send result. That means it successfully sent the order. This is the log message that we can see here. So this is the object of send result, and notice it has some information like the topic and some headers, the key, the value, basically the payload of that event, timestamp, and some metadata that we can access. So this order service successfully created an event and sent it to the Kafka topic. And since it was able to send the notification, we should see the message in the notification service, because it will trigger that event listener. So let's go to the notification service, and here we don't see anything. Why? Because Why is not able to read the Kafka listener? Because we missed the annotation at the red component. So this class was not scanned actually. So let me restart the notification service. All right. And this time we see some activity related to Kafka because now this class is getting scanned. And so everything related to Kafka is happening now. All right. So let's make a new request, order to send the request. In the order service, we see another message. That means it sent another notification. And in the notification service, this time we see the message received event and the payload of that event, that order create and order to. All right. And that's how different services work together in event-driven architecture. So some services generate the event and those events are sent to the Kafka topics. And then there are different services which listen to those topics. And whenever there is a new event, they consume that event and start their processing. All right. And further, they can also generate new events. So let me quickly recap what we did. On the producer side, where we have to send the message, we use Kafka template. All right. And once we have the Kafka template, we can use any method, which is as simple as calling a method on the object. We are passing the topic, the target topic, and then the payload of the event. And on the receiver side or the consumer side, we are using the Kafka listener annotation, passing it an ID and the name of the topic. So whenever there is any activity on this topic, this listener will be invoked. And that's how we consume the events. Now let's move on. So this was the happy path in which the producer sent the notification to the Kafka topic and the consumer or this listener picked the event from that topic and it was able to consume that event. But let's say the consumer is not able to consume the message properly. And so you can say the processing failed and we want to retry the same thing. So producer is generating the event, but the consumer is not able to consume that event properly. So it wants to retry. How do we do that? We can easily handle such scenarios using Retryable Topic, which is another annotation or another mechanism provided by the Spring framework. So let's try to do that as well. Now to implement the Retryable Topic, we need to add another annotation, which is Retryable Topic. And it needs some information. So the first one is attempts. It defines the number of attempts we want to retry the operation. By default, it is 3. So we can simply choose the value 3, or we can change it to, let's say, 5, 7, or whatever we think is right for the use case. So let's start with 3. Then the second thing that we can provide is the back-off mechanism. Because let's say this particular consumer or this listener was already under heavy load, and for some reason, it failed while consuming the event. And if we retry without backing off, it may further degrade the performance of this listener. So we want to retry, but with a back off. And that's what we define here. So in the back off, we can provide some information, some data values that can control the back off mechanism. So the first one is delay. Now delay defines after how much delay we need to retry. So this is the first attempt. And if we provide, let's say 2000 L, that means after 2 seconds retry. Then we can also provide the max delay. Max delay means this is the maximum delay that we can afford, that we can wait. All right. So in this case, let's say we can say 10,000 L. That means for 10 seconds. And the third parameter we can pass is the multiplier. Multiplier is used to define the timing of the next attempt. So that means, let's say if the delay is 2 seconds, so the next attempt will be at 4 seconds or after 4 seconds, which is the delay 2 seconds multiplied by 2. So how do we test this? If this method completes successfully, that means the listener consumed the event successfully. So somehow we need to abruptly terminate the execution of this method. Now to test this, what we can do, we can simply throw an exception here. Like that. Now, when there is a new event on the topic and this method gets invoked, this method will throw an exception that will trigger the retry mechanism. So let's test that. Let me restart this service. So the service is up. Let me clear the console as well. And let's trigger a new request. So a new event is generated. And now notice the logs. So this time we see the exception in the logs. It means there is some error. Let's see what happened. we see this message received event which is coming from this method. So this is the first occurrence when this method was invoked, and right after consuming the event, it will throw a runtime exception, which is written over here. So that means it now has to retry the operation. So we will now notice the attempts and the delay between those attempts. This is the first attempt, and notice the timing 15, 44 and 49. And after encountering the exception, it will retry the operation. So that will be the second attempt. And this is the message from the second attempt. Notice the timing. This is 15, 44 and 51. So notice the delay. This is 49 seconds and this is at 51 seconds. So that is a delay of approximately 2 seconds. And that's what we mentioned here. That's what we configured in the backoff mechanism, the delay of 2 seconds. So after this delay, the second attempt was made. Now let's see what happened after that, because it will throw an exception this time as well. So there will be a third event. And this is the third event. Notice the timing between the second attempt and the third attempt. So if you notice 15,410 and 54,895, this is approximately a delay of 4 seconds, because this time it will use this multiplier to calculate the next difference, which is this delay multiplied by this multiplier. So a delay of 4 seconds. And that's why we see this delay here. And that is the use of multiplier. But right after that, we see the exception finally, and it terminated, because although we have not exhausted the max delay, but we have exhausted the attempts. There are no more remaining attempts. So it will stop retrying the operation and it will throw that exception. That exception will be caught by the framework. And that's why we see this exception on the logs. And what happens to this message, this event, basically, this event will now be sent to the dead letter queue. That is the home of all the undelivered and unprocessed events. And if we go down, scroll down, we see this message, that received message in DLT listener. All right. So this event was sent to the dead letter topic. So that concludes the discussion for this demo, for this video. In this video, we saw how to develop microservices following event-driven architecture using Kafka. How can different microservices communicate with each other in a decoupled way using Kafka? And we also saw how can we implement the retryable topic, how can we implement the backoff and retry mechanism using Kafka. So that's all for now. See you in the next video. Thanks for watching.